Saxon Algebra 1, Lesson 40, the quotient rule for exponents, and the distributive property of rational expressions that contain negative exponents. Let's review our definitions and rules of exponents. First of all, the definition of x to the n. If n is a natural number, then x to the 1 is x, and x to the n, where n is bigger than 1, is x multiplied by itself n times. Then we have the product rule. If x is not 0, then x to the m times x to the n is x to the m plus n. For example, x squared times x third is x to the 2 plus 3, which is x to the 5th. Here we can see why that must be true. X squared is x times x, and x third is x times x 3 times, and so we have 5 x's multiplied. We add the exponents. Remember this definition. If x is not 0, then x to the 0 power is 1. And a similar definition, if x is not 0, then x to the negative n power is 1 over x to the n. The last definition can also be stated backwards. If x is not 0, then 1 over x to the n is x to the negative n. And if we replace n with negative n, I should say the opposite of n, then we have, if x is not 0, then 1 over x to the opposite of n is x to the opposite of n, which gives us x to the n. These definitions are made so the product rule remains true even when n is a negative number. They also give us the quotient rule. Here's the quotient rule for exponents. If x is not 0, then x to the m over x to the n is x to the m minus n. For example, a to the 6th over a to the 2nd power is actually equal to a times itself 6 times over a times itself twice, and we can cancel 2 of the a's in top and bottom, leaving 4 a's in the top, which is a to the 4th. And you see that a to the 6th over a to the 2nd can also be thought of as a to the 6 minus 2. That gives a to the 4th. The quotient rule and the definition of negative exponents also gives us this result. If x is not 0, then x to the m minus n is 1 over x to the n minus m. Here are some examples. X to the 6th over x squared is x to the 6 minus 2 by the quotient rule, which is x to the 4th. We can look at this another way. X to the 6 over x squared is 1 over x to the 2 minus 6, or 1 over x to the negative 4. So you see 1 over x to the negative 4 is the same as x to the positive 4. X to the 6th over x to the negative 2 is x to the 6 minus negative 2, and that's 6 plus 2, so it's x to the 8th. We can look at it another way. X to the 6th over x to the negative 2 is 1 over x to the negative 2 minus 6, which is 1 over x to the negative 8. Again, see that 1 over x to a negative power is x to the positive power. 1 over x to the negative 8 is the same as x to the positive 8. How about this one? X to the negative a over x to the b. By the quotient rule, this is x to the negative a minus b. Or we can look at it as 1 over x to the b minus negative a, which is b plus a. Here's a longer example. We have 3 variables mixed. If we concentrate on the x's, x to the negative 5 over x is x to the negative 5 over x to the 1, and that's x to the negative 5 minus 1. We look at the y's, y to the 6 over y to the second is y to the 6 minus 2. And we look at the z's, that's z to the 1 over z to the negative 3, which is z to the 1 minus negative 3. Now we simplify those exponents. We have x to the negative 6, y to the 4th, z to the 4th. We can rewrite this without negative exponents. That's y to the 4th, z to the 4th, over x to the 6th, because x to the negative 6 is 1 over x to the positive 6. Now we will consider the distributive property of rational expressions that contain negative exponents. We will look at some examples to understand how to do this. Here's our first example. We need to use the distributive property on this expression. So we multiply the 3x to the negative 2y third times what's inside the parentheses. And that gives us 3x to the negative 2y third times the first term plus 3x to the negative 2y third times the second term. We multiply the numbers, 3 times 2 is 6, and we multiply the x's by adding their exponents. That's x to the negative 2 plus negative 3. And we multiply the y's by adding their exponents, y to the 3 plus negative 5. Then for the second term, we multiply the numbers. That gives us 15. And x to the negative 2 times x to the 6 is x to the negative 2 plus 6. And y to the third times y to the negative 2 is y to the 3 plus negative 2. Then we simplify the exponents. We have 6x to the negative 5 because negative 2 and negative 3 add to negative 5. Y to the negative 2 because 3 and negative 5 add to negative 2. And for the second term, 15x to the 4th, because we have x to the negative 2 plus 6, y to the first, because 3 minus 2 is 1. Next, we interpret those. The negative exponents put the variables in the denominator with positive exponents. So the first term is 6 over x to the 5th, y to the second, and the second term is 15x to the 4th, y, because y to the first is y. Here's another problem. We need to apply the distributive property. It would be easier if we rewrite this expression without fractions. We can take advantage of negative exponents to do so. Notice the 3x to the negative 2 over y fourth becomes 3x to the negative 2 y to the negative 4. And also notice the terms inside the parentheses can be rewritten using negative exponents. Now we distribute. And we have the following. And then we simplify each term by adding exponents. The first term becomes 3x to the 0, y to the negative 5. And then we have minus the second term, 12x to the negative 4. You see x to the negative 2 plus negative 2 is x to the negative 4. Y to the negative 1, because we have y to the negative 4 plus 3. Now, the x to the 0 is 1. So the first term is 3 times 1 times y to the negative 5th. And then we can interpret the negative exponents. And we have 3 over y to the 5th minus 12 over x to the 4th y. Let's use the distributive property, simplify with all variables in the denominators. Well, we won't worry about that. We'll first rewrite this expression without fractions. Then we have k squared b, p to the positive 2, times ab to the negative 1, k to the negative 2, minus 4p squared b to the negative 1. So where we had denominators, we moved them to the numerators and changed the signs of the exponents. Now we distribute, and then we group together the variables that are the same and add their exponents. We get k to the 0, b to the 0, ap squared, minus 4k squared b to the 0, p to the 4th. Now those 0 powers are 1s, so we can drop them out of this expression, and we have ap squared minus 4k squared p to the 4th. Well, we were told to write the expression with the variables in the denominators. So we will simply make reciprocals of the variables and change their exponents to their opposites. So the first term becomes 1 over a to the negative 1, p to the negative 2, minus the second term 4 over k to the negative 2, p to the negative 4. So you see, it's probably easiest to do these problems by rewriting the fractions with negative exponents, so we no longer have fractions, use the distributive property, and use the product rule on the exponents, and then at the end interpret if necessary. This is the end of Lesson 40. Your assignment, problem set 40 on pages 163 and 164 of your book.